our presentation, the first thing you are going to notice about our capstone, it's a little different from all the others. What we're doing is we are researching a machine learning topic. And in particular, we're asking the question, is there something special about the hierarchy structure and comparing that to the normal setup of a neural network? To do so, we built a hierarchical neural network and we built a regular neural network. And we isolated the variables just between, we made small networks with only one dense layer, no convolutional layers, really trying to isolate in on that structure. I'm joined today by my teammates, Puri and Rick. And with that, I'm going to hand things over to Puri to talk about the data and the methods. Puri?
Thanks, Joe. The data we picked for this research is called Fashion MNIST. This data set is widely used in the deep learning research. So these allow us to be able to compare our results across other previous research on the same data set. The data set is balanced among all 10 different classes, as you can see on this screen. All right, next, like what Joe mentioned before, our research is focused, about the neural network. I believe that some of us here might be familiar with it, but some may not. This slide shows you a simple architecture of the neural net model. It takes input data, and within the hidden layers, the weights in the bias term will be updated using the backpropagation method. Then the final predictions are made. The number of the node in the output layer corresponds with the number of the prediction classes. Now, let me walk you through some definition here. When we refer to a flat neural net or flat NN model, it means that we feed the full data set into a single traditional neural net model that makes a final prediction for all classes within itself. It gives one output node for each class. So for our Fashion MNIST data set, it will be 10 nodes for the 10 classes. Simple enough, right? For the hierarchical neural networks, or HNN, we start with feeding the full dataset into the first model. But instead of it making the final decisions, the first model only classifies the dataset into subgroups, which then feed into the new neural net model in the next level, until the last level where the final predictions are made. We can look at HNN like a stack of flat NN models. So let's see how it would go with our data set. The full data set feeds into the first model, which only predicts either clothes or goods. Then these feed into the next model to define their subcategories and so on, until the model in the last level make the final prediction for all 10 classes. You may be curious how we build this model. We built our models using the TensorFlow and Keras, which are open sources. You can go grab it right now. We customize our code to implement the HNN model. The code makes it so easy to change and modify the structure of the hierarchy. So we built a lot more, not just the one I previously showed you. And we make this publicly available on GitHub. If you are interested in our tool on HNN, just give us a holler. Our ultimate goal of this research is to prove that the HNN model will outperform the flat NN model using the Fashion MNIST dataset. We built a flat NN model with the 3 HNN models, which Rick will talk more about how we decide each hierarchical structure and how those models perform. Over to you, Rick.
Thanks, Puri. Overall, our first HNN model only had a slight improvement in accuracy versus the flat model and a significantly longer training time. But the real interesting part came in changing the hierarchy structure. And we'll go about how we did that. But by changing the hierarchy, we got about almost a full 1% increase in accuracy. So the key thing is HNN is not a single thing. The structure, how you define the hierarchy has a significant impact. So let's take a look at how we got to those. with our first H&N model results, we looked at each category and had a couple of insights. The first one being that coats and pullovers are being confused for each other in both the flat model and the first H&N. We wanted to look at what we could do to possibly improve that. The second thing to note was that the flat model actually did better on t-shirts than the H&N, and vice versa on shirts. So we took this information and tried to adjust our hierarchy. On the next slide, we'll show you where we started. This was based on previous research on how to divide the hierarchy. And you'll notice that the clothes are kind of separated into how you would use the clothes. The types of shirts are grouped together, coats its own separate thing, etc. On the second hierarchy, we took our insights of coats and pullovers being confused for each other. Instead of building a hierarchy on how you would use the clothes, it's more about separating the images. And you could see coats and pullovers look very similar in the images. In the first hierarchy, they were in separate submodels at the final layer. So this shift in the hierarchy structure puts them in the same final model so that we could try to get better separation between these two categories. The next, the other insight we looked at with t-shirts doing better on the flat model, we shifted that, separated that out at a higher level in the hierarchy, at the medium level, instead of sending it down to be compared against others in the fine. And we moved the shirts into this model of other tops to be compared directly to pullovers and coats. So let's take a look at how those hierarchy shifts impacted our results. Pullovers and coats, the first insight we had, the first shift we made in the hierarchy, you could see a significant increase in the prediction performance for both coats and pullovers as we step through those hierarchy changes. So it's showing the impact of how that structure affects not just overall accuracy, but individual classes. And then that last shift having to do with the insight on t-shirts and shirts, we don't see a big boost or change at all really in the prediction performance on these classes. But note that we only looked at 3 hierarchies here, and they were based on intuition, our EDA of the results. But what we really have here that's interesting about the H&N is this new tunable parameter. The structure of the hierarchy itself is a tunable parameter, and you can take this and do a search across different possible combinations on the hierarchy structure and perhaps identify one that is better for shirts or t-shirts. So if you have a priority class, you have this new tool available to this tunable parameter in the hierarchy structure. I'm going to hand it back to Joe to tie all this together.
Thanks, Rick. To summarize, what we found was that overall accuracy of the hierarchical neural network compared to a flat neural network, we showed modest gains at the expense of time. So what that means, or what you can take away from our research, is that hierarchical neural networks, they provide a new tunable parameter. Hierarchical neural nets, you can, if you were interested in exploring this topic, you could look deeper into optimizing the structure. And another area of research is you could separate out, you could use the hierarchical structure to separate out non-interesting classes. If this type of research is interesting to you, we would love to hear from you and pass the baton off to you guys. All right, thank you very much. And we look forward to hearing your feedback.